Okay, so we decided about the fundamental counting principle. If you're making two choices and you want to know how many total options do you have, you multiply the number of options for your first choice times the options for your second choice. So if I'm choosing a new car and I'm deciding between a Camry and a Camaro, two excellent cars that start with C, and I got to choose a car color, black, gray, white, or yellow, first I'm going to choose which car, 2 options. Then I'm going to choose which color, 4 options. So that means there's 8 total possibilities. I could get a yellow Camaro or I could get a white Camry. But what if the choice you make for one of the questions changes how many options you have for another question? That would be a situation where your choices are not independent. Your choices are independent if an earlier choice doesn't really affect how many possibilities there are for the later choice. And that's what we've seen so far. Like, all of my choices are kind of separate from each other. They don't influence each other. Or they don't influence how many options I have for other choices. But, Camrys don't come in yellow. So if Camrys don't come in yellow, what are we going to do? How do we count it? So if your choices aren't independent, then you have to count separately depending on the earlier choice you're making. So my choice of car is going to affect how many colors I can choose. So I'm going to consider separately, what if I choose a Camry, what if I choose a Camaro? So if I choose a Camry, I can only have black, white, or gray, let's say. So there's 3 possibilities. If I choose a Camaro, I could have any of the 4 colors. And so now we can add up all of the possibilities because I'm choosing either a Camry or a Camaro. So from the last video, that was like we're adding up the options because I can't choose both. And so that gives me 7 total possibilities. So that's my first note, is you got to be a little bit careful applying the fundamental counting principle because you are assuming that all of your choices are independent of each other when you do. Let's choose a week. Let's choose a week of desserts. So I want to choose a dessert for every weekday: Monday, Tuesday, Wednesday, Thursday, Friday. So fundamental counting principle, 1, 2, 3. So that's like, here's choice for Monday, Tuesday, Wednesday, Thursday, Friday. If there are no restrictions, and these are all the desserts that I keep in my house, which is true, you may object salad's not a dessert, but sometimes you got to choose salad. So what was it? All right, so five options for every choice. So I've got 5 options for what dessert I'll have on Monday, and 5 more for what to have on Tuesday, and 5 more for what to have on Wednesday. So like this. So this is equal to 5 to the 5th power, which is, some reasonably medium-sized number. And then just to be clear what all this means, it's like maybe I'll choose pie all week. Awesome. That's really different than if I chose pie and then Peeps and then ice cream and then more Peeps and then salad on Friday. So that's what this is intended to capture, is all of the different sequences of desserts that I could have. Okay, but what if I want to impose some extra conditions? What if I don't want to eat the same dessert twice in a row? That's going to affect the number of options I have for each new day. So on Monday, I could still choose any of the desserts. So I've got 5 options. But then on Monday, I've already made a choice of one dessert. So like if I chose pie, now I only have 4 options left on Tuesday because I'm not going to choose pie again. And if I chose Peeps on Monday, then I still only have 4 options on Tuesday because I'm not going to choose Peeps again. So this is a situation where my choices aren't independent. The choice that I make on Monday affects the options I have on Tuesday, but the difference is it doesn't affect the number of options I have on Tuesday. No matter what I choose on Monday, I still only have 4 options on Tuesday because I'm leaving out the option that I chose on Monday. So even though the choice I make on Monday affects my options for Tuesday, you can still use the fundamental counting principle because no matter what I choose on Monday, I've still got the same number of options for Tuesday. That would not be true if my particular choice of dessert on Monday changed how many options were available on Tuesday. So like if I chose pie on Monday, maybe now, let's say I have to eat salad after eating pie. So now if I choose salad on Monday, if I choose pie on Monday, I only have one choice for Tuesday, salad. But if I choose anything else on Monday, then I've still got all 5 options. Now I can't really use fundamental counting principle in a straightforward way because the number that I would write here for my options depends on which particular thing I choose for the previous day. So again, like there's a lot of things to think about. But I think all of them make good common sense. So that's kind of the trick about this thing is you can't just mindlessly use rules. You got to actually think about what you're trying to do. Okay, so back to it. Right. So my rule was I don't want to eat the same dessert twice in a row. So whatever I choose on Monday, I'm not going to choose it on Tuesday. So now I've got 4 options. Whatever I choose on Tuesday, I'm not going to choose on Wednesday. So that means I also have 4 options on Wednesday. And whatever I choose on Wednesday, I'm not going to choose on Thursday. So I still have 4 options and 4 options. So this is going to be 5 times 4 to the 4th, which is a different set of possibilities. Why don't you try one? Let's say that I want to eat the same dessert on Monday and Friday, but other than that, there are no restrictions on what I'm choosing. So you think, how would you fill this out if I know I want to eat the same dessert on Monday and Friday? Okay, here's the answer. So if I'm choosing my dessert on Monday, I've still got 5 options. And on Tuesday, I've got 5 options. But on Friday, I don't have 5 options anymore because I'm forced to choose, I've forced myself to choose the same dessert that I chose on Monday. So whatever I chose on Monday, I'm going to do that on Friday. So really, I only have 1 option on Friday. So that would be 5 to the 4th power as the total number of different possible dessert sequences. Okay, let's do another one. What if once I have chosen a dessert, I never want to eat that dessert again for the rest of the week? Now, how many options do I have for each day of the week? Think about it. Okay, here's the answer. So on Monday, I've got all 5 desserts available. On Tuesday, I'm not going to choose my Monday dessert. So I only have 4 more options left. And on Wednesday, I'm not going to choose my Monday or my Tuesday dessert. So now I only have 3 options left. And then on Thursday, I only have 2 options left. And by the time I get to Friday, I have to eat the one that I didn't choose so far, which is probably salad. So there's 1 choice left. So this is, you don't know a good notation for this yet. This exclamation mark is called factorial. And 5 factorial literally means 5 times 4 times 3 times 2 times 1. We'll get to that in the next video, though, which is about permutations.